Hi, my name is Todd Carter. I'm a Principal Premier Field Engineer working for Microsoft. In this module, I will introduce you to the new ways of accessing data stored in SharePoint List using LINQ for SharePoint. I will start with providing an overview of why you might want to consider using LINQ to access many different types of data. We will then jump into LINQ syntax and the changes made to the .NET framework to support LINQ. Then finally, we will show how you can use LINQ to SharePoint provider to access SharePoint List data and provide the code readability and reliability through strongly typed objects. Okay, so what is the motivation for LINQ? Here's a typical system.data query of a database. Note that this sample combines two languages, C# and Transact SQL, or T-SQL. Note too that the connection string and query are not checked at compile time, and the data is accessed through a data table or data row, and is not returned as strongly typed objects. Here's another example of a typical system.xml query. Note it requires a lot of code to do anything with XML, and much of the code is parsing, and once again, once parsed, does not offer a strongly typed objects to work with. Finally, take a look at this camel query in SharePoint 2007. Note the use of strings that cannot be checked at compile time, and the cryptic query syntax. You may have used similar camel query code in conjunction with SPQuery or SPSite data query objects within the SharePoint object model. It is important to note LINQ to SharePoint is used to query list data and cannot be used for cross-site collection queries. This means LINQ for SharePoint is a replacement or alternative for SPQuery, however does not replace the need to use the SPSite data query object or camel. LINQ began development in 2003. The goal was to make it easier for developers to interact with SQL and XML in a more consistent manner because the programming models were so different. The result is a query language that can work across a wide variety of sources: SQL, XML, files, and now SharePoint lists. LINQ uses compile time checks and compiler-generated types to return its queried data. This allows Visual Studio to provide IntelliSense back to the developer, which too improves the developer's ease of development. Having unified syntax allows the developers to concentrate less on how to access the data and more on using the data to solve problems or perform a specific task at hand. At this point, we should jump into a demo where I can show you some of the cool features of LINQs and how you can use LINQ to access many different types of data, which you may have already been using different methods to access today.
Hi, in this demo I want to show you how we can use LINQ to access different data types using a very simple construct within C# that really is pretty consistent across all the different data types. So we'll open up our, our project here, and we'll dive right into the source code. We'll go ahead and hide this. So our user control, we're going to have here, it's a web part that's that's hosting a user control. We're going to have several buttons on the interface that's going to do different things. Excuse me. For this first example, what you'll see, we're just accessing directory info, and make the font a little larger. Accessing directory info for the C drive, and then we're enumerating through, getting a numerator on the directories. So this is using LINQ. So what we're doing is we're selecting the directories here. This is our enumerator, and within that enumerator for each item, there's a name. There's a name property, and what we're doing is taking that name property and we're creating a new object. And this is an object that's kind of created on the fly for us. This object is being stored here, so we're storing an enumerator of objects. So we're using this var syntax, which is really the compiler at the compile time will determine the proper object that's going to be created here. Then what we can do is actually use that object in our enumerator. So this is that special object that's going to be created for us on the fly here is I. And notice we have this name is available to us. So you notice the anonymous type here that's being created and automatically for us, and then a collection of those are being stored here in Q. So very simple to do. What we're doing is just running through the loop and then just adding those to our results, our result list. And this is this is all the directories on my C drive. The same sort of thing can be done looking at the processes on the system. So I have the various processes. I can do the same sort of syntax here, nothing really different. So that's kind of interesting. So we've got processes we're enumerating and then directories, but we're using pretty much the same syntax. Now we actually have an array of strings. Same sort of thing here. What we're doing, however, here is I can actually do an order by. So I can actually use ordering to sort the names if I want. So what we're doing here is we're storing we have another string array that we're using, and notice I can just take that in this particular example and just data bind that directly to my list, rather than what I was doing previously was kind of looping through the results and adding them to the list one at a time. My final example we'll show you is an XML document. So this is kind of an in-memory XML fragment that I have that has just some contacts. And we can do the same sort of thing. We can take the XML, load it into a document, and then we can actually look for descendants of contact, and then we want to find the first name, and we're again creating this anonymous type. We've got now a collection of anonymous types, and we run through accessing those as well. We have another example, and if this one looks a little funny to you, well, don't worry about this. We'll actually talk about the collection and initializers and object initializers later. But let's just look at the contract object we're dealing with. So we have a first name and a last name. Now, the contact itself, the first name and last name is interesting, but normally the way you might view this contact is first name with a space potentially and the last name, or you could think about a last name comma first name sometimes is seen. So we don't have to necessarily represent that here in our object. What we can do is we can create these. What we'll do is load up a lot of these objects. And we'll instantiate these, give first name and last names of these objects. And then what we can do is actually loop through creating a new anonymous type. But what we've done is this anonymous type that I'm creating, I'm giving it a new property called display name. And then what I'm doing is I'm formatting the first name and last name to have that space in between them. And then so now we have this new display name. Now I'm also adding this first name and last name to the new object too. So this anonymous type is being created here in Q, and we're actually accessing here in I. Let's take a look at what that guy looks like in IntelliSense. And IntelliSense is really neat because it works here. So there's my display name, there's my first name, which was the other attribute I gave, and my last name. So that's where these are coming from. So when I'm doing this select new, what I'm doing is creating a new anonymous type. And if I give it a name, this is the name that will be used to access the values. And if I don't supply a name, it's this part of the name is actually used. This part of the field name is actually used to create that new field. So that's how we're able to get through and navigate through and create this new anonymous type, but still be able to use it here using IntelliSense, and then of course. The compiler does the right thing for us in creating these anonymous types. So let's save this, and we'll just take a look at the project in action. So we'll hit F5. We're adding the solution to the project right now. Okay, so let's go ahead and edit this page, and we'll add that web part to the page. All right, we'll save this. Now we'll hit our files query. So this is where we're actually querying for the files that are on my C drive, or the directories actually that are on my C drive. It's enumerated out. And then we'll look at the processes. Same sort of thing. There's the array, that string array that we had. We're able to run through there. Notice how it's ordered in alphabetical order. We'll query that XML. And then finally we'll query that collection. And so this is that that object that we created, and remember we created that display name, so I'm showing the display name for these users. So this is the first name and last name formatted. So as you can see, LINQ is, we're able to access many different kinds of data, relational data, but still be able to use the same type of constructs and same kind of programming language to access all of that data. And this concludes the demo.
Now let's take a closer look at some of the technology you just saw demonstrated. Several language enhancements to C# and VB.NET were made to add support for LINQ. These enhancements made it possible to write compact LINQ queries in a single statement. Many of these enhancements are available to you as a developer outside of LINQ, and you may find new constructs and functionality useful in your development process. We will spend the next few slides talking about each of these items in a bit more detail. Generic support was first added to the .NET Framework in version 2.0. This allows for non-generic types to reference generic types, much like C++ templates. LINQ makes heavy use of this capability and uses the generic IEnumerable interface to return query results. The iQueryable interface is implemented by LINQ providers to add provider-specific support for querying different data sources and sorting. Automatic properties are a shorthand way of declaring properties on a type without having to specify member variables within source code. The compiler omits getters and setters and compile time, so there's no need for developers to define member variables directly in their source code. Object and collection initializers are another shorthand way to initialize an object. Rather than instantiating a new object and setting member attributes, a more compact and readable method of object creation can be used. This concept extends to almost any type, including collections which support generic types, as you see here in this example. There are many types within the .NET Framework, and there are some cases where you may want to extend or add additional functionality to these classes. In many cases, these types are marked sealed, which means they cannot be extended through inheritance or subclassing. Extension methods help solve this problem by allowing the developer to create a custom static types which have specially formatted methods which define functionality and the type they are extending. LINQ has extension methods it uses to extend some of the IEnumerable and iQueryable functionality built into the .NET Framework. In this example, we have created a new static class called MyExtensions with a single static method which does a check to see if a string appears to be formatted as a valid email address. Note the construct of the method and the use of this. Note also how the email handler class we can use IntelliSense to discover the new extension methods when using these within our projects. Anonymous delegates are methods which are created at compile time by the compiler. Depending upon if they access member variables of encapsulating type, determines if they are static or instant methods. The syntax for anonymous delegates is not always well understood across all developers and can become difficult to read depending upon how the source is formatted. Lambda expressions make the accessing of objects easier, and that the code appears to be much more straightforward and its purpose is more clear. Going one step further, query syntax offers yet another readability alternative to lambda expressions. The syntax shown here has a very different syntax. However, will have the same result. The second query is using linked query syntax, and is widely used and accepted as a more readable alternative when dealing with linked queries. And finally, our last feature we will discuss is anonymous types. These are new types which are created at compile time for which a developer can create fields or properties or make up a new type. In this example, a new anonymous type is created with 3 fields: job title, person name, and project title. A collection of these new types is stored in the variable Q, which is of type var, or variant. At compile time, the compiler will admit a replacement type and ensure all type checking is handled. Again, developers will find IntelliSense very useful in these scenarios and will help guide the use of these new types. As our first demo showed, there are several link providers available today. What's new, however, is the link to SharePoint provider that allows developers to access SharePoint list data, much how we showed SQL and XML data being accessed. Now let's dig into the details of link to SharePoint. In previous versions of SharePoint, CAML was used to execute queries against and across lists. CAML was difficult to use because it was an XML-based query language that was unique to SharePoint. CAML also used no compile time checking because it was written as a string into the code and used in objects like spQuery and SP site data query. LINQ provides for the creation of entity classes that represent lists and list items. These entity classes are strongly typed, use IntelliSense, and use compile time checking. Link to SharePoint development is similar to other LINQ development experiences, like link to entities. To use link to SharePoint in your project or solution, a reference needs to be added to the SharePoint link provider, Microsoft.SharePoint.link. Note link to SharePoint is a server-side only concept and cannot be used to access lists from remote clients. SharePoint uses REST and the list data service to support remote client access of lists. This topic is covered more fully in the Client Object Model Ignite training module. Using link to SharePoint in your projects is this very simple 3-step process. We start by generating entity classes, which encapsulate the SP list item and data access. We then move on to create a data context, which is used as a connection into the SP list. And then finally, we use the link syntax to write our queries, which define what data we want returned. Entity classes are created that represent lists. These entity classes are created using a command line tool called spmetal. spmetal ships as part of SharePoint and is located in the bin directory. It supports a simple command line interface, which accepts parameters, which direct the tool to which site, list, and code generation options will be used to generate entity classes. By default, without a parameters.xml file, spmetal will attempt to create entity classes for every SharePoint list within the site. In many cases, only one or a small number of lists are actually going to be used, and it may be desirable to create entity classes just for these lists. spmetal supports this option by allowing the developer to create a parameters.xml file to specify the list by name for which entity class generation is desired. Keep in mind that any changes to the list or content types being used will need to have their entity classes regenerated to ensure they are in sync with the latest changes. As mentioned earlier, the link to SharePoint provider functionality ships in the Microsoft.SharePoint.link assembly. Your project will need to include a reference to this assembly before your project can leverage the functionality found within the generated entity source file. Once the entity source file has been generated by running spmetal, it needs to be included in the Visual Studio project and compiled along with the rest of your solution. At the heart of link to SharePoint is the data context object. The data context object is used to access the SharePoint list data and is passed a URL to the site containing the list which correlate to the entity classes generated by spmetal. The generated entity classes actually derive from SharePoint to Link's data context implementation, which means it is extremely easy for developers to instantiate the entity classes, passing the site's URL, allowing the data context to wire up the necessary connection. Once created, the entity class is then used to submit queries back into SharePoint to retrieve the list data. Relationships allow for the querying across lists where one list is used as a lookup to another. Association encapsulates the lookup and provides easy access to business data using strongly typed code. Using LINQ, you don't need to create the association manually. With a camel-based approach, these associations were very difficult and problematic to set up and troubleshoot. LINQ uses the association attribute to define the associations within the entity class. Any list which has a lookup to another list will have the association attribute automatically added to the proper field by SPMetal. Much of the power of LINQ is enabling the developer to create relationships which cross lists in a repeatable method. The developers use strongly typed members to access members of several lists to build potentially very complex queries. In this example, we have two lists, the employee list and the project list, where an employee is associated with a project. This query selects all employees whom have projects with due dates that fall within the next 5 years. Under the hood, LINQ's provider generates the camel necessary to retrieve the data from SharePoint, which removes the developer from having to build, maintain, and troubleshoot complex and error-prone queries. In addition to querying SharePoint list information, the SharePoint to LINQ provider also makes it easier to modify list data through an object tracking mechanism built into the data context. All changes to the entity classes are tracked, and then once ready to commit those changes, the developer would then call submit changes method on the entity class to update the list in a batch process. Now let's take a look at the demo where we'll look at using LINQ to SharePoint to access and join two SharePoint lists and conduct very specialized query operations, which would have been extremely difficult to do using the camel model.
Hello, in this demo I'm going to show you LINQ to SharePoint and how you can actually access list information, list data using LINQ for SharePoint. So I have on my team site a couple lists that I've created. One is a projects list that lists the projects that I might have going on, and I have a description, a due date, and then I have the primary contact. Now this list, these contacts are linked to the employees list, and again I have a list of employees, job title, the team they're on, and then contributions and milestones here, and then back I have a link back to the project itself, so I can actually go back to the project that comes out from the projects list. So I have effectively a doubly linked list here. So I have the two lists that both link to each other, forward and backwards here. So we want to access these and join these lists together and get a nice view of what's going on. So what I want to do is I want to use links for SharePoint to do that. When using LINQ, I need to use this tool called SPMetal. So I have a project that I've created. It's a web part. We're going to use SPMetal to create a entity class, and then we're going to actually use that class within the LINQ web part to access the information. So a couple things whenever you create a project, what you want to do in the references, you want to make sure that you add a reference to this SharePoint right here. This Microsoft.SharePoint.link right here is the guide that you want to add a reference to ensure that you have the proper code available. And then we also want to run this SPMetal. Now SPMetal is going to generate that class for us. Now the way you run SPMetal, it's a command line object. It's actually in a command line program. It's actually in the 14 Hive under the bin directory. So I've got a command file here that I run and I'm just setting the path in here. I pass the web parameter is required. It's pointing to the site collection that you're going to be accessing. There's parameters. I'll show you what this parameter XML looks like in a second. And then we have this language, so the language of the code we want to generate. There's a C# is the default. So if you leave this off, it'll generate C#. Also, we have the codes, the name of the file that we want to create. So we're going to call it entities.cs. And then let's go back over here. And then of course, then the namespace another optional parameter that you may want to specify. So this is the namespace for the code that's going to be used in here, and I'll show you what that looks like in a little bit. So we'll just execute this code, and it will actually generate that class for us. So let's take a look at the parameters. So by default, whenever you run this, if you don't specify the parameters, what it's going to do is going to go SPMetal will hit the site, run through every list that it finds, generating this entities class for every list. Well, that may not be necessary, right? You may have specific lists that you want to go after, and in that case, what we're going to do here is we're going to use this parameters file to actually go after a specific list. In our case, for this demo, it's the projects and the employees list. So this is the format of the XML document here. So we have the class, so the name of the class. We want to be a public class called entities, and then we're gonna run through and generate the necessary code to access the projects and employees, and then we're going to exclude all the other lists. So that's just the basic schema of this file. So let's go ahead and run SPMetal, and I've just got it right here. So what it's doing now, it's accessing those lists and generating the entities.cs file that we'll use in our project. Okay, so it's done. So let's go ahead and include that in our project. So I'll do show all files. There's the file that was just created for us. I'll include that in our project. And then let's take a look at this. Now there's the namespace that we specified in our command line, and then all of this code is generated for us. The class that we really care about is this entities class, and this is the class we're going to be accessing to capture most of the information we care about when we access these lists. Now notice it derives from this data context. So this is the way, this is the guy that's actually going in and querying this SharePoint itself. So he's the one accessing the list information. So a couple things that we have here that are kind of interesting. So we notice we use all these attributes. So we've got our employees and we have our projects. So we have a list of projects, project items, and employee items. So that's we've got basically each list item will be of a project item or employee item that we're going to access. So I'll show you what that looks like. Let's take a look at the code for this visual web part that I created. And let's kind of move that over. Now the code here is fairly simple. What we want to do is we want to start with adding our reference to system.link as well as our Microsoft.SharePoint.link. That's that reference that we added earlier. And then we're going to add our reference to the linked list web part, which is that namespace for our entities class that we just created. So then let's take a look. So in our page load, what we're going to do is we're going to create this string builder. This is not really used here in this example, the first run through here, because I'm going to show you what we're going to use that right here in a little bit when we're going to look at the log. So we have this logging capability that we can actually look at the camel that's actually created for us, but we'll look at that in a little bit. Right now, let's just go through the code that we have. Let me kind of zoom in here. There we go. So the way we use our entities class is we instantiate a new instance of it, passing in the URL that we care about that contains our list that we're going to access. And so at this point we have our data context. In that case, we're going to call it the DC. So here's our code, the link code. And so let's just take a look. What is this doing? Well, it's using the data context. It's accessing the employees list, and then it's pulling every employee where the employee's project, its due date, is less than 5 years from now. And then we're going to order by the project due date. And then we're going to actually select get the employee. So what this is going to contain is a list of employees, so or employee item, if you will. So what we just did was we actually just traversed the employee we looked at the project the employee was involved in, we looked at the due date for that project, and we're able to filter out a list, or actually in this particular case, order the list of employees by the project due date. Now, what I also did here was I also wanted to show you how we can actually read and write data back. So what I've done is I'm looping through here, and I'm actually writing back to the employee's contribution in milestones. So you may have remembered back on the page back here, we have this contribution in milestones, and notice they're very low numbers. And so what this demo is going to do is we're going to actually just set that to be a little bit higher number probably in this, and just to show you that we can actually write back. So then what we actually do is we make our changes, and then back to our data context, we call submit changes, and all those changes are then written back in a batch back into SharePoint. So it's a full read and write fidelity. Then what we're going to do is we're going to do the same sort of query here, but notice there's a little difference. So in this particular case, we got back these employees. Down here, we're going to get back an anonymous type. And so what we're doing is by doing this select new, we're creating an anonymous type. And I'm going to create this type. It's going to have several fields: a job title, person name, and a project title. And then what we're going to do is take that and just going to data bind it directly into a repeater that we have. And of course, then we'll potentially catch any exceptions if we needed to, or just close out our table. So let's take a look at what this code looks like in production. So let's go ahead and run this. I'll just hit F5. So right now the solution is being added, features being activated, and it's been deployed. And so we should start up Internet Explorer. Okay, here it comes. All right, so the first thing we want to do is we want to edit this page and add our web part to the page. So our web part, it's going to be under Ignite, under Visual Web Part, we'll hit Add. It's added, and we'll go ahead and hit Save. So let's take a look at what this has done. So we have our nice table here with a project and a responsible party. So the project, I received the project name here, so Ignite, and then or MCM 2010, and then I have over here the responsible party. So I actually have the person, the project manager's name, and then their title right here. So very simple way to go and grab this information. Now, to show you back over here on the employees list, notice my contribution milestones has changed. So we were able to notice that the write functionality actually did work for us, and it actually wrote back to our list. So let's go ahead and stop this. Now, it seems pretty simple, and probably a pretty common way to access this information, right? So when you have data that's related. However, it's very difficult to do in CAML. So what I want to do is we have this on the data context, we have this log functionality. And what this log functionality will do is actually log the query that's being submitted into this query.xml file for us. So let's use that. In fact, let's go ahead and just let's go ahead and use that. We'll save this off there, and let's go ahead and rerun this. Now this is, writing to a file this way is probably something you wouldn't want to do in production, especially because it's you're writing to the disk, as well as writing to a single file doesn't without any, as you saw, any locking there is not going to work very well when you have a system that has several users using it. So this is again something for test, and just something I just wanted to show you what this looks like. The camel that we actually don't have to create. So here's our list. Let's go see if that document was created for us. It was. Let's take a look at what this guy looks like. Let's format this a little bit. So by using LINQ for SharePoint, this is the camel that you did not have to write. So as you can see here, this is the date, 5 years. So the date time now plus 5 years. And this is the 2015. So this is part of the query that we're bringing back. We've got the order by here. We have the view fields. The project field names, we have our joins. So we didn't have to write any of this code. Now also here's that second one that we wrote. Again, something we don't have to write as well here. So we actually did 2 different queries, so we have both of them logged into this file. Something else I wanted to show you before we finish up. Let me go ahead and stop this guy. Now, your list normally is going to contain, we have that title, right? That title field. And what happens is it kind of gets kind of confusing sometimes, right? So when we look at this, for example, we went from the employee, we got the employee's project, we went and got the employee's primary contact, and then we got the title. So what does this really contain? What this really contains is the person's name, right? Now we could have received that off of the employee dot title, but what we were showing you here was the way I could traverse over into the project, find the primary contact, and actually traverse back. So we're actually traversing forwards and backwards here. But this title doesn't really make sense. What we really probably want to do is we want to call that the person's name. So what we can actually do is go take a look at this guy. We'll go to the definition, and notice we have title. Now it's going to go back to the field type is text, and the field name is actually the title. But in here, since we have this level of redirection, what we can do is refactor this. We can call it person name. So then what that does is it actually makes our code look a lot nicer, because actually what we're doing is we're actually accessing the person name. So we actually, instead of having an employee with a job title and a title, what we now have is an employee with a job title and a name. And something to also notice is we have full IntelliSense here too. So I have the ID, the person's, the project they're working on, the due date here. So we have is full IntelliSense, and we also have the type checking as well. So we don't have to worry about accessing with the SP list item and accessing into the title, and then casting that to the right type. This is all done for us via this entities class that was created using SP Metal. And that's going to conclude this demo. Thanks a lot.
In this module, we discussed many of the reasons why LINQ is a great model for developers. We looked at the various query syntax available to the developer when using LINQ. And finally, we introduced you to LINQ to SharePoint, which is the new type-safe way to access SharePoint list data without knowing the camel query language. This concludes this module, and I really hope you enjoyed what you learned today and can apply this knowledge to your SharePoint solutions. I also would invite you to review the other Ignite presentations.